Okay, I'm finally getting around to making this recording for you. Sorry it's taking me so long. Okay, so if we look at this particular problem right here, if you want to know what F is, you can do the finger trick. You can memorize the there's two special triangles, and those two special triangles that you have is that you have a 45, 45, 90 triangle. And if you look at that, that's in a ratio of 1 to 1 to radical 2. So when you draw your triangle, you're going to get a triangle where these two angles are 45 degrees. And you're going to get 1, 1, radical 2. So then you just change those into x values or n's or something like that. So we have an n, 1 n, and n radical 2. So if you had a right triangle that was 45, 45, 90, and they told you that the side length was 5, then the hypotenuse is 5 radical 2, which you can get there through Pythagorean theorem. It's going to be 5 squared plus 5 squared, and you take the square root of that. So that is 2 times 25, and the square root of 25 is 5, so you get 5 radical 2. Or you have a pair of 5s if that's the way you did your simplification of your radicals. The other particular special triangle that you have is a 30, 60, 90 triangle, and those are in the ratio of 1, radical 3, and 2. And if you do that hand trick and you put down your 60 degrees, you see you have 1 finger, you have 3 fingers, and then you have your palm, which is 2, which I'll draw that on the board here in a little bit. So as you look at that, when you talk about that 30, 60, 90 triangle, if you're going to know the special triangles to help you get this answer, opposite of 30 would be 1, opposite of 60 degrees would be radical 3, and opposite of your 90-degree angle would be 2, and that's where you get that ratio from. And these are in increasing order, so that's where you're going to work with them at, or I mean, that's how you can help realize where they go. Is radical 3 is somewhere between the value of 1 and 2. It's between the square root of 1 and the square root of 4. So just a minute, I'm getting a phone call. Okay, sorry about that. So you're in that ratio of 1 radical 3 to 2, and then you can put an n with it or an x, and then you can find your side lengths from that. So if you look at this particular triangle, what they are telling you, if you make a relationship to your special triangle, is that between the right angle and 60 degrees, this has a length of 7. So if you are looking for the hypotenuse over here, it's going to be that value of 7 doubled. So your answer for this particular problem would be 14. So I can come over here and I'll go ahead and enter in 14. Now before I submit that, I'm going to show you another way you can solve this. And this would be using the hand trick. So sorry if my hand's not drawn very well here. I'm not very good at this. I'm trying to be better. Okay, so there's your hand, and if you remember, this is going to be 0 degrees. Here's 30, here's 45, here's 60, here's 90, and then it goes cosine, comma sine, which is the same thing as the x value and the y value, and then you have a 2 in the palm of your hand. Remember, your fingers are radicals. So if you look at this particular problem, there's 2 different ways you can look at it. One of them is to say that if you have your 30-degree angle here, then you know the opposite side over the hypotenuse. So an opposite over hypotenuse, when you do some old hippie caught another hippie tripping on acid, opposite and hypotenuse deal with sine. So the sine of 30 degrees is equal to the opposite side over the hypotenuse. So things that you can do, different things that you can do from here. If you had your calculator, you would put this over 1, and then you would cross multiply, take 1 times 7 and divide by the sine of 30. So you would type it in your calculator like this. And that would give you 14. But since you don't get your calculator, then I would go back to the hand trick. So for the hand trick, I would fold in this finger of 30. So I would fold this finger in. And then what you have is the signs. So you want to look at the fingers that you have below the one that you fold in. And the sine of 30 degrees is, remember your fingers are radicals. So you have the square root of 1, which is just your pinky, over 2. So we know that the sine of 30 degrees is equal to, the square root of 1 is just 1, so you get 1 over 2. So if I go back to my problem that says the sine of 30 degrees is equal to 7 over f, then the sine of 30, if I take that left-hand side, the sine of 30 is equivalent to 1/2. That's equal to 7 over f. And if you cross multiply, you get your 14. So that's the other way you can do it. Now, if you don't want to do that, I don't think I can back up and change it. If you don't want to do that, here's what you're going to have to do is take your hand and you're going to do 60 degrees. So I'm going to do this in black. So if I do 60 degrees, then 7 is the adjacent side and f is the hypotenuse. And adjacent and hypotenuse deal with cosine. So then you would say the cosine of 60 degrees is equal to adjacent over the hypotenuse. Put this over 1 again. If you had your calculator, you could say it's 7 divided by the cosine is 60. But since you don't, now remember there's this 30 here. So this finger is back, the one that's in red. So what I'm going to do now is I'm going to fold my pointer finger, because there's my 60 degrees. So this is my cosine, and here's my sine, looking at the hand. So the cosine of 60 degrees is 1/2, and the sine of 60 degrees is 3 fingers here, so it's radical 3 over 2. But what we want is the cosine of 60 is just that 1, which is your thumb, over 2, the palm of your hand. So you get 1/2 is equal to 7 over s, so you cross multiply and you get 14 over 1, or 14. Okay, so let's look at another example. And I'm going to try to do these, well, I don't know. I'll do them with both the special triangle and the other way so that you can see how to do it.
Like Aaron and Jada's move, and that's when
Okay, Austin, as we look at this one, what we're going to notice is we can go back to that special triangle again. This is a 30, 60, 90 triangle. So the ratio is 1, radical 3, and 2. And one way to help you with that is if you go to your hand, if you look at your hand, sorry again for my drawings here. My fingers getting fatter or something. Okay, so if you look at your hand, and if you were to hold in this 60 degrees, you see you have 1 and you have radical 3, and the palm of your hand is 2. So that gives you this ratio of 1, radical 3, 2, if that helps, if you need a way to help understand what that triangle should look like. So if here's 30 degrees, then you're going to have n over here, or 1n, and your 60-degree angle is going to be radical 3, or n radical 3, and your hypotenuse is going to be 2n. So come up with that ratio, and remember that ratio is making reference to the sides opposite. All right, in your special triangle then, if you look at it, you see that this base value down here, opposite of 60 degrees, has this value of 3 radical 3. So that tells you that n is 3, and they want to know what is this side length over here. So it's going to have a value of 3 because that's what n is. Now, if not, you go back over here to your finger. I don't think I can fix that very well. So I got to redraw my hand here. Nice thumb. All right, there's your hand. And as you look at that triangle, there's different things that you can do again now. So you can either use 60 degrees or you can use 30 degrees. If you are going to use 30 degrees, this is the C is the opposite side, and 3 radical 3 is the adjacent side. So opposite and adjacent, and some old hippie caught another hippie tripping on acid. Opposite and adjacent deal with tangent. So we're going to say the tangent of 30 degrees is equal to the opposite side, which is C, over the adjacent side, which is 3 radical 3. Again, just go ahead and put that over 1, and if you had your calculators, you would take 3 radical 3 times the tangent of 30 degrees on your calculator. Since you do not, what I would do, if you don't want to look at that special triangle, what I would do is look at what is the tangent of 30 degrees. The first thing you need to do when you're looking for the tangent of 30 degrees is you need to fold in your finger that's 30 degrees, which is your ring finger. Then after you do that, you flip your hand. All right, great. Now I got to try to draw a flipped hand. All right, so my flip hand, because remember, you're, well, that's not very good. So your flipped hand is going to be tangent, because that's where you see your tangent. So there's your pinky, here's your ring finger, here's your middle finger, your pointer finger, and then you're going to have your thumb out here once you flip your hand. And we write tan on the back of our hand because that's where we see our tangent. So after you have that, you fold it in that 30-degree finger, which is now going to be right here, because here's 0, 30, 45, 60, and 90 is your thumb. So you folded this in, and you want the tangent. So all you are looking at for the tangent is you're looking for your fingers. So if you look at your fingers, you have 1 right here. So the tangent of 30 is 1 over, it's a square root of 1, but that's 1. And then you have 3 fingers here. So it's 1 over radical 3. The denominator is not from anything that's right here. It's just your fingers. So it's 1 over radical 3, and that's equal to C over 3 radical 3. Now, from the previous method, by using the special triangles, we know that that height was 3, or opposite of 30 degrees was 3. If we calculate this, you cross multiply. So you're going to take 3 radical 3 times 1, and you're going to divide by radical 3. The radical 3's cancel, and you are left with 3. That same value as we had before. So the answer for this particular problem would be 3. Go ahead and put that in. Sorry for the hands that look so bad, but hopefully it's bringing a smile to your face. Okay, I'm going to erase this. Okay, I'm not for sure what method you're going to use. If you do that 30, 60, 90 triangle again, if that's the method you're going to choose to use, you are going to have n, where this is 30 degrees, and then the bottom is n radical 3, and that hypotenuse is 2n. So they're telling you that n has a value of 4. So if you want to know what is s, this is the same position as s. So s would have a value of 4 radical 3. If you want to use the hand trick, you could use either 30 or 60, and I forgot to mention that in the last problem, and that's going to make a difference of whether you use, oops, my ring finger got bigger or longer than my middle finger, and my pinky's fat. I'm so sorry. Okay, so we look at this, and there's 2 different ways you could set this one up. One way you can set it up is the tangent of 60 degrees. And if you look at 60-degree angle, the opposite side is S and the adjacent side is 4. So you would have S over 4, and that's one way you could solve it. The other way you could solve it is you could use your 30-degree angle, and if you use 30 degrees, your opposite side is 4, and the adjacent side is S. So then you get the tangent of 30 degrees is equal to opposite over adjacent. So they look like reciprocals of each other. So now what you got to do is you got to figure out which one of those two do you prefer. Does not matter to me. Once again, if you had your calculators, I'd put that over 1. But since we don't, we're not going to worry about that. I'm going to get rid of that for a second then. I should not have probably put it there. Because we're going to use the hand trick because you don't get your calculator. So as we use the hand trick, the first thing you do, remember, is fold in your finger. So if you're going to go with this first one, if the tangent of 60 is equal to S over 4, you fold in 60 degrees. This is 0, 30, 45, 60. So you fold in your 60-degree finger. You're going to flip your hand. Okay, so now I got my fat pinky here. And then I got this finger that I folded in, which is my 60 degrees. And then I got my middle finger, and then I got my, oh, I folded in the pointer finger. What am I doing? That was the 30-degree one. I'm trying to do it backwards here. So I got my pinky, I got my ring finger, I got my middle finger, I folded in the pointer finger, and then I got my thumb over here, big fat thumb, sorry. So this is the one I folded in. So I'm looking at the tangent, and the tangent of 60 degrees are those 3 fingers, which is radical 3, over my big fat thumb, which is the square root of 1, or just 1. So if I set it up using this, the tangent of 60 equals S over 4, you get radical 3 over the square root of 1, which is 1, is equal to S over 4. And when you cross multiply, you get 4 radical 3, which is what we got in the green when we used the special triangle. Now, if I chose to do it differently, maybe I chose to do the tangent of 30 degrees. If I do the tangent of 30 degrees is equal to S over 40, I have to fold in 30 degrees, which is my ring finger. So if I draw that hand, then it's going to be my pinky. Fold in your ring finger, your middle finger, your pointer finger, and your thumb. So if your ring finger is folded in and you are looking for the tangent, so you got your hand upside down, then what you have is the tangent of 30 is equal to the square root of 1 over the 3 fingers that remain after your folded finger, your ring finger. So the square root of 3. The square root of 1 is 1 over radical 3. That's the tangent of 30 degrees, and that's equal to 4 over S. So once again, you cross multiply, and when you cross multiply and then divide by 1, you get back to 4 radical 3 again. So there's your answer. So let me see if I can get 4 radical 3 typed in here for you, so I can move to another example. I think you probably have it, but I'm hoping that I get to an example where I have a, 45, 45, 90 triangle. I think I'm going to pause this, and I'm going to go ahead and answer through a couple of these until I get to a 45, 45, 90 triangle. If you need more examples like this, let me know. Okay, I changed my mind. I decided to go ahead and show you this one just in case you use your special triangle. Because if you look at this one, the hypotenuse is 2. So you've changed this 2n. Maybe I should even do that differently. 2n is equivalent to 2. So if you divide both sides by 2, that means n is equal to 1. And this is the side that they are looking for, which is opposite of that 60 degrees. So n is 1, and you end up with radical 3. So your answer is just radical 3. Now, if you wanted to do it with the hand trick, you either pick 30 or 60 degrees. Leah, move away from that because it's going to pick you up into that. Move to the back. They're going to pick up that recording. So you either use 30 degrees or you use 60 degrees. if you use 30 degrees, you were talking about the adjacent side, and adjacent and hypotenuse would be cosine. So the cosine of 30 degrees is equal to adjacent over hypotenuse. And if not, you're going to use the sine of 60 degrees is equal to opposite over hypotenuse. Hopefully you got the finger thing down right now. So if you do the cosine of 30 degrees, that has a value of radical 3 over 2, because you're referring to that palm, that 2 that's in the palm of your hand, is equal to u over 2. So if you cross multiply, 2 times radical 3 divided by 2, the 2's cancel and you get radical 3. If you choose to use the sine of 60, hold in your pointer finger, because that's 60 degrees. Sine is the bottom values or your y values, so you get radical 3 over 2 is equal to u over 2, and if you cross multiply and divide again, you get the square root of 3. I just wanted to point out, if you use that special triangle, what you have to do in order to find that n value. So your answer is just radical 3. I really hope this next one happens to be a 45, 45, 90 triangle. All right, let me answer this one and I'll get back to you. Okay, as I'm still trying to get to a 45, 45, 90 triangle for you, Austin, I ran across this one, and this is where the finger trick works a little bit better than the triangle, because if you have 30 degrees here, this is 6 inches, and they're telling you this is n, and here's 60 degrees. In your special triangle, this is going to be, and I shouldn't do that. I'm going to change this here. So in your special triangle, they're telling you here's 30. This is going to be n. This is n radical 3, and this is 2n. So the values that they give you in your triangle say that n radical 3 is the same thing as 6, and they want to know what is this value right here. So the first thing you would have to do is you would have to find n. It's not as easy as just having a coefficient to your radical in this case. So you would have to divide, and you get 6 over the square root of 3. If you rationalize the denominator, you're going to get 6 radical 3 over 3. The 3 goes into 6 2 times, and you get 2 radical 3. So that's n. So n is the same thing as 2 radical 3, and you get an answer of 4 radical 3. Now, as I mentioned, the hand trick might work a little bit better for this one. If you look at it, you have the hypotenuse. I don't care if you use 30 degrees or 60 degrees. I'm just going to use the 30-degree angle. So you have the adjacent side, so that means we're going to say the cosine of 30 degrees is equal to the adjacent over the hypotenuse. So the cosine of 30 degrees, if you look at your hand trick, you're going to fold in your ring finger, and cosine is the top, so that's going to be radical 3 over 2, and that's equal to 6 over n. So you cross multiply to give you 12 over radical 3. Then you go ahead and you rationalize the denominator, which is going to give you 12 radical 3 over 3. But then 3 goes into 12 4 times, and you end up with 4 radical 3 for an answer again. The same thing that you had if you use the special triangles and solve for n. So whichever method you want to use. Okay, finally, a 45, 45, 90 triangle. So we talked about if you want to make reference to the special triangle, where you have 45, 45, 90, then it's in the ratio of 1, 1, radical 2. So you let the ones be n's and put an n in front of radical 2. So if you look at this particular example, they tell you the hypotenuse is 2 radical 2. That tells you that n is 2. That's a 1n there. It kind of looks like an m. But your two sides then will have lengths of 2, and your answer should be 2. If you are going to use your fingers, then you go to what you have is you're going to have the opposite or the adjacent. Does not matter, because at 45 degrees, cosine and sine are both radical 2 over 2. If you use your finger, you fold in your middle finger, you get radical 2 over 2. So if you look at it, there's your thumb, your ring finger, your middle finger, your, pointer finger, ring finger. Oh man, I can't even get them in the right spot. You have your thumb, then you're going to have your pointer finger, your middle finger, your ring finger, and then your pinky. So if you fold in 45 degrees, you're folding in your middle finger, and cosine is radical 2 over 2, and sine is radical 2 over 2. So for this particular one, I don't care which one you use, the sine of 45 degrees is equal to the opposite side, which is p, over the hypotenuse, which is 2 radical 2. So the sine of 45 degrees is radical 2 over 2. That's equal to p over 2 radical 2. And if you cross multiply, you got to take 2 radical 2 times radical 2, and you divide by 2. The 2's cancel. Radical 2 times radical 2 is 2. So your answer just happens to be 2. Okay, I hope these help. If you need another example with the 45, 45, 90 oops, I don't need that. So if you need another example with a 45, 45, 90 triangle, let me know. Otherwise, I'm going to try to find examples of something else for you. Here's another one. I guess I could do this one for you real quick. So if we look at this one, maybe I can leave some of this on the board. Oh, well, that didn't work so well, so I'll just draw it again. So if you look at this one, if you know the special triangles of 1n, and n radical 2, then they tell you that this value over here happens to be 4, and they want to know the hypotenuse. So n is 4, so this is going to be 4 radical 2, and there's your answer for that right there. M happens to be 4 radical 2. If not, use your fingers. Once again, you're going to have the 45 degrees folded in. You could use the cosine. The cosine of 45 degrees is equal to adjacent over hypotenuse. The cosine of 45 again is radical 2 over 2 equals 4 over m. So if you cross multiply, you get 8 over radical 2. If you rationalize the denominator, you're going to get 8 radical 2 over 2, and 2 goes into 8 4 times, and you get back to an answer of 4 radical 2. All right, I hope that helps for just a review of sine, cosine, tangent, where you cannot use your calculator. Let me save this. I'll get it sent to you in an email, and then I'll go over examples with inverse sine.